Welcome back. Let's take a look at this question. Question number 7 reads, a pendulum with bob of mass 5 kilograms is held stationary at a height 8 meters above the ground. When released, it collides with a block of mass 2 kilograms which is stationary at point A. The bob swings past A and comes to rest momentarily at a point a quarter h above the ground. The diagrams below are not drawn to scale. Immediately after the collision, the 2 kilogram block begins to move from A to B at a constant speed of 4.95 meters per second. Ignore frictional effects and assume that no loss of mechanical energy occurs during the collision. The question reads, calculate the kinetic energy of the block immediately after the collision. For 3 marks, usually just a single formula, EK equals half mv squared. We'll substitute half, the mass is 2, the velocity was given to us 4.95, and don't forget to square it, giving us a kinetic energy of 24.5 joules. Next question reads, calculate the height h. And this is for 4 marks. Now, since they mentioned that no loss of mechanical energy, what we can then say is that the total mechanical energy in this system is going to be conserved. Now, since the block was stationary, any mechanical energy that it gained is going to be from the ball which lost mechanical energy. So the block gained 24.5 joules of energy. The energy before was 0. That means, again, the ball lost 24.5 joules of energy. So we can set up an equation. We can say that the mechanical energy of the ball at the top minus the mechanical energy at the bottom is 24.5 joules. We can then expand on this. We can say that mgh at the top minus mgh at the bottom is 24.5. I'm leaving out kinetic energy because remember, at the top and at the bottom, the question states that the ball comes to a rest. So there's no kinetic energy. We can then substitute 5 times 9.8 times h minus 5 times 9.8 times a quarter h equals 24.5. We can then solve for h. H is 0.67 meters. Okay, moving on to the next question. The block moves from point B at a velocity of 4.95 meters per second up a rough inclined plane to point C. The speed of the block at point C is 2 meters per second. Point C is 0.5 meters above the horizontal as shown in the diagram below. During its motion from B to C, a uniform frictional force acts on the block. Let's take a look at the question. 7.4 use energy principles to calculate the work done by the frictional force when the 2 kilogram block moves from point B to point C. So we'll start with a free body diagram showing all the forces, including the components acting on this object. So there's the normal force, there's the perpendicular component of gravity, there's the parallel component of gravity, and there's friction. Now I'm going to label them, specifically the two that are important. Friction is NC, meaning it's a non-conservative force, and the parallel component is a conservative force. Now we can use a formula that is WNC, since they are asking for the work done by friction. So we can say WNC is equal to the change in potential energy plus the change in kinetic energy. Since friction is the only non-conservative force there, the work done by friction will be the change in EP plus the change in EK. Let's expand. So the work done by friction is mg, open bracket, the final height minus the initial height, plus half m, open bracket, the final velocity squared minus the initial velocity squared. Now we just have to substitute. We know the mass, we know gravity, we know the final height, we know the initial height. We know the final velocity at the top, we know the initial velocity at the bottom. And when we solve, you get negative 10.70 joules. That's it.